Let's find the limit as x goes to 0 of x minus 3 over x using a table. So first of all, we can't just plug in and get our answer, because when we do, we would get negative 3 in the top and 0 in the bottom. So we get a number divided by 0, which tells us we have a vertical asymptote. 0 over 0 indicates a whole, and the limit is going to exist and be finite. A number divided by 0 indicates you have a vertical asymptote. So my limits are going to be infinity, negative infinity, or d and e if we have opposite direction arrows. They could be up, down, or down, up. So we want to figure out, is the limit infinity, negative infinity, or does it not exist because we have opposite arrows? So we have a vertical asymptote. There's a couple ways to approach this using a table. So we could still just use our standard table and choose some x values close to the x value we're supposed to be approaching, which in this case we're taking the limit as x goes to 0, and see what the function gives us for x minus 3 over x. So we could approach 0 on both sides to see what the left-hand limit and the right-hand limit are. So we could put it right in the middle and approach on the left and on the right and get closer. So to the left would be like negative 0.1, negative 0.01, negative 0.001, and see what that left-hand limit would be. This is where we're going to be able to conclude the left-hand limit. And then we could get close on the right. So starting further away, we would have 0.1, 0.01, 0.001, and see what the right-hand limit would be. This is kind of the slower way of doing it. This is not how I would typically do it for a vertical asymptote, but I'll show you this way with numbers, and there's so many ways to make these tables that are all correct. But one way is to just plug into the function and see what the y values are. So if we plug in negative 0.1 to this function, negative 0.1 for my x minus 3, all divided by negative 0.1, my x, I'm getting 31 for that y value. If I plug in negative 0.01 instead, the y value should be 301. Keep in mind you might need parentheses around that numerator to get the correct answer, since it's more than one term. And then we would plug in negative 0.001, and we get 3001. So we went from 31 to 301 to 3001. So we're getting infinitely large. This left-hand limit is going up to positive infinity. Of course, we get an error if we plug in 0. Exactly, we got negative 3 divided by 0, which is undefined, or an error in our calculator. And so we plug in stuff to the right. So negative 0.001 is very close on the right. You get negative 2,999. If you get a little bit further away, you're at negative 299. And then lastly, plugging in 0.1, I'm getting negative 29. So as we get really close on the right, we start at negative 29, go to negative 299, and then get even closer, and we're at negative almost 3,000. So we're headed to negative infinity. So you can actually plug in each x and get out a y, which I think gets a little bit confusing, because like right when I first plugged in, I got 31. I might be tempted to think that that left-hand limit was actually 31, unless I plug in closer numbers and see that 31 became 301 and then 3001 as we got closer to the x value. So normally for a vertical asymptote, how I would recommend making a table of approaching values, I would approach the x value I'm interested in on both sides. So we want to approach 0. We already know it's a vertical asymptote because we plugged in and got a number divided by 0. 0 over 0 would be a whole. A table of approaching values would be more useful. A number divided by 0, it almost is more confusing to plug in and see what those concrete y values are, because they are continuing to go up or down as you plug in numbers that are closer. It doesn't stop at 31 on the left side and then negative 29 on the right side. You have to keep plugging in closer numbers to see. So if we plug in 0 and we just want to go a little bit to the left, say negative 0.1. Plugging into the top, we'd have negative 0.1 minus 3. So we would have a negative numerator. And then in the bottom, we have just our regular x, which is negative 0.1. So we get a negative divided by a negative, which is always positive. So our left-hand limit is going up to infinity. I think it's easier to do it this way than to look at the y value being 31 when you plug in negative 0.1. You know you're headed up to positive infinity for that vertical asymptote because you can get a negative divided by a negative when you plug in any number to the left. that is near 0. If we plug into the right, for the right-hand limit, I'm just going to plug in 0.1 and see which type of infinity I'm headed to. So into the function, I'd have 0.1 minus 3, which is going to be negative. And then it's divided by 0.1, which is positive. So a negative divided by a positive is a negative, and we're headed down to negative infinity. So what's my final limit? If the left-hand limit is infinity and the right-hand limit is negative infinity, your fingers do not meet. So the limit as x goes to 0 of x minus 3 over x is d and e. One is going up, the other is going down. The limit does not exist. So this is how I would recommend making a table once you know that it's a vertical asymptote. And this is the type of table I would use if it were a hole. That first type of table would get me to a nice number if it were a hole, but the second type of table where you don't even plug in and see what the y value equals, you just see the sign of the y value, is a bit more useful for vertical asymptotes. But both should ultimately get you to the same final answer.